Hello everybody, welcome to TRIGONOMETRICAL Learning Mathematics videos. Today we'll be discussing about trigonometry, and in that we'll be solving the practice problems related to trigonometrical identities. So let's start. The first question of this video is that we need to prove secant A minus tan A upon cosecant A plus cot A is equal to cosecant A minus cot A upon secant A plus tan A. Now there are two ways of solving this question, so I will be doing both the methods. It's up to you which one you want to choose. So first of all, the first method includes applying the identities. That means we will be using these two identities, that is secant square theta minus tan square theta is equal to 1 and cosecant square theta minus cot square theta is equal to 1, because we need secant A minus tan A as well as cosecant A minus cot A in the numerator. So, and we have the similar values with the opposite sign in the denominators. So here I'm going to write both the identities, that is secant square A minus tan square A is equal to 1 and cosecant square A minus cot square A is equal to 1. I am taking this as equation 1 and I am taking this as equation 2. As both the equations are equal to 1, so we can equate these two. So I'm going to equate secant square A minus tan square A with cosecant square A minus cot square A, because both of them are equal to 1. So I'm going to write here secant square A minus tan square A, that is equal to cosecant square A minus cot square A. Now if we consider secant square A as A square and if we consider tan square A as B square, so it becomes A square minus B square, and we can apply the formula of A square minus B square as A plus B into A minus B. Similarly, on the right hand side, if I consider cosecant square A as x square and cot square A as y square, again this becomes the formula of x square minus y square, so I can write it down x plus y into x minus y. So if we apply the formula here, we will get secant A plus tan A into secant A minus tan A. And on the right hand side we will get cosecant A plus cot A into cosecant A minus cot A. Now if we look at what we need to prove, in the numerator on the left hand side we have secant A minus tan A. So I'm going to write here secant A minus tan A, and in the denominator we have cosecant A plus cot A. So I'm going to bring this cosecant A plus cot A here and I'm going to write it down. That is cosecant A plus cot A. Now on the right hand side on the numerator we are left with cosecant A minus cot A, and if I bring the secant A plus tan A here in the denominator, we can get what we need to prove. So I'm writing here secant A plus tan A. So here we have proved that the left hand side is equal to right hand side, hence proved. Now the second way of doing this question is to solve the left hand side. So here what I'm going to do, I'm going to rationalize the denominator. That means I will be multiplying the numerator as well as the denominator with the conjugate of the denominator. Now what is a conjugate? Conjugate is that when we write the denominator with the reverse sign. So here if we reverse the sign we will get cosecant A minus cot A, and in the denominator also we're gonna write cosecant A minus cot A. In addition to this, I will be taking the conjugate of the numerator also. So here I will be multiplying the numerator as well as denominator with the conjugate of the numerator, which is secant A plus tan A into secant A plus tan A in the denominator. Now if we consider secant A as A and tan A as B, and here this is A and this is B. So if I consider this A plus B into A minus B, so on multiplying A minus B with a plus b, I will get the formula as a square minus b square. Similarly, I can use the formula for cosecant a plus cot a into cosecant a minus cot a. So on applying the formula, we will get secant square a minus tan square a in the numerator along with cosecant a minus cot a. And in the denominator, we will get cosecant square a minus cot square a along with secant a plus tan a. So now if we look here, secant square theta minus tan square theta is equal to 1. So this bracket, the first one, becomes 1, and in the numerator we are left with cosecant a minus cot a. Similarly, in the denominator, cosecant square a minus cot square a will be equal to 1 as per this identity, that is cosecant square theta minus cot square theta is equal to 1. So I can write 1 here, and in the denominator we are left with secant a plus tan a, which is equal to the right hand side. So the left hand side is equal to right hand side, hence proved. So in this question, all you have to keep that in mind. We will be rationalizing the denominator as well as the numerator. Then only you will get left hand side equal to right hand side. Now the next question. In that, we have to prove that square root of 1 minus sine a upon 1 plus sine a is equal to secant a minus tan a. I will be solving this question by taking the left hand side. I will be solving this question by rationalizing the denominator. That means I will be multiplying the numerator as well as the denominator with square root of 1 minus sine a. So here I am writing square root of 1 minus sine a in the numerator as well as in the denominator. So in the numerator we will get 1 minus sine a whole square, and in the denominator we will get square root of 1 plus sine a into square root of 1 minus sine a, as the square will get cancelled by the square root. So in the numerator we will get 1 minus sine a, and in the denominator we can apply the formula of a plus b into a minus b, taking a as 1 and b as sine a. So we can write this as a square minus b square. Now the denominator will become square root of 1 square minus sine a whole square. So now I'm going to rewrite this. The numerator will be same, that is 1 minus sine a, and the denominator can be written as 1 minus sine square a. Now if we consider the first identity, that is sine square theta plus cos square theta is equal to 1, I can find out the value of sine square theta minus 1. So here we know that sine square theta plus cos square theta is equals to 1. So if I take sine square here, I will get cos square theta equal to 1 minus sine square theta. So I'm going to substitute the value of 1 minus sine square theta as cos square theta in the denominator. So the numerator will remain same, that is 1 minus sine a, and in the denominator we will get cos square a. Now this denominator can be written as square root of cos a whole square, where square will get cancelled by the square root. So we are left with 1 minus sine a in the numerator and cos a in the denominator. So on the left hand side we have 1 minus sine a in the numerator and cos a in the denominator, but still on the right hand side we want secant a minus tan a. So what I'm going to do now, I'm going to separate the denominator. That means I will write 1 upon cos a minus sine a upon cos a. So now as we know that 1 upon cos a is equal to secant a, and sine a upon cos a is equal to tan a. So now this gives us the right hand side. So the left hand side is equal to right hand side, hence proved. Part 1 ends here. Thank you for watching this video. For more videos, you can visit our website transelearning.com or YouTube channel Trans eLearning. Have a great day.